Hello and welcome to this first episode of Monty Python Coding. Today's topic is Python Decorators. Today I will be discussing what Python Decorators are, how we use Python Decorators, and why we use Python Decorators. First, let's get started by defining what a function is in Python. A function in Python is something that takes a number of arguments as input, does some logic, and then returns an output. In this very simple example, I have defined a function that simply adds 1 to any number passed to it. So, if I call this Python code, it will output 8, because 7 plus 1 is 8. And I can then change that to 6, for example, and it will output So, the idea behind functions is that they are small pieces of code that can be used multiple times. You wouldn't normally have a function that adds 1 because that's just as simple as, say, 6 adds 1 or 2, but you'd usually have a few more lines that do things. Now, in Python, functions are variables, so they can be passed as arguments to other functions. In this simple example we have here, we simply have a function that calls any function passed to it with the specified arguments. So for example, if we run this Python code, it will call the same add1 function that we previously defined, but without actually calling it. It will call function with arguments and passes the variable add1, which is simply a reference to the object of the function add1. This will then go and call that reference and actually call the function with the argument 5, and thus giving us an output of 6. Next, let's go on to the topic of scopes in Python. Python functions define a scope in which any variable defined within it cannot be accessed from the outside. So if we run this example Python code we have here, you'll see that it will print from the parent function and the first child and the second child. But we cannot go call first child because it's not defined. It is only defined within parent, and only parent can call it. Also, because of this scopes, functions can do various things based on input given to them, and possibly even return another function. For example, here, in this example, the parent takes a number and defines within it first child and second child. And if the number is 10, it will return first child, otherwise it will return second child. And we define foo and bar here, example, they're variables, but they will be references to functions, so we can later call them down here, with parent with the arguments of 10 and 11. So then, if we run this Python, we'll see that foo and bar are functions. This is an object in the scope of parent, and first child and second child. And then when we call foo and bar, because we've passed different things, and parent has done logic and returned a different function depending on the input given, we get two different outputs. This is a very cool feature of Python. Now, let's actually move on to the topic of decorators now that we've covered this necessary background. A decorator is simply a wrapper around a function. It is a function that will return the function again that is passed to it with extra code. For example, this function here simply prints that before the function is called and after the function is called. And this function could do anything, and these things could do anything before and after the function is called. So if we run this, we'll get before some function is called, then it calls the function and prints we, and then after function is called. And to decorate it, we simply pass the reference to some function as a variable to some function. And again, because of scopes, this inside function can reference some function from the myDecorator. And then we can go and call just some function, but it will be decorated with this decorator. Now this isn't a particularly pretty example, so Python has some syntactical sugar to do it. You can specify at a reference to a decorator function, which is just any normal function that takes an argument, which is a function, before a function, and it will automatically decorate it. So we don't have to have this line of code here, it's just this code, and this code is the same, but it will have the exact same effect as what we did over here. Now let's move on to some actual useful real-world examples of decorators. In this example, it is used as a timing decorator. So it will get the current system time, then call the function, then get the current system time again, and subtract them to get the time. And then we have a big, complicated, well, it's not big, but it will take a while to run, which will simply just add all the numbers from 0 to 100,000, or 10,000 even, in a loop. So it will give us the sum of all the numbers here, and then we can, because it's a decorator, that decorator then does the returning instead of the function, so we can print the output of my function, which will actually be the output of this wrapper because it is decorated, and it will give us the time that it took to run the function. Now let's show another real-world example here. We're creating a Flask app. A Flask is just a simple HTTP server in Python, but have you noticed that we're never passing a reference to the function to Flask to handle endpoints. But what we are doing is decorating the wafflecats function, which will simply return cats, which will be sent back to the browser, with app.root, which will tell it that when someone visits our app/waffles, it will call this function to then handle that. This code is not runnable, but it is simply an example of how function decorators are used in the real world. You have been watching an episode of Monty Python Coding on Python Decorators. To summarize, we showed you what Python decorators are. They call another function, which will then decorate that function with additional code. How you use them with the syntax before defining a function, and why you would use them with some real-world examples. Thank you for watching. I will see you